Hey guys, and welcome to this video tutorial on the C programming language. So here what we want to do is we want to convert a number in base 10 to binary or to base 2. So let's go ahead and get started. First I'm going to write the description of the program of what this program does. So this program converts a number in base 10. So that's our normal number system, like 1, 2, 3, 4, 5, or 6, etc. And it converts that number to base 2, which is also known as binary. So I'll put aka binary. Okay, so how are we going to do this? Well, let's see how it works. So suppose that we have a number in base 10, our normal number system, and that number is 50. We would like to convert 50 to its binary equivalent. Okay, and the steps to do that, so I'm going to put to convert 50 to binary steps here, is first what we do is we take that number 50 and then we're going to mod it by 2, which is because we're using base 2 or binary, and then we get a remainder which will either be 0 or 1. Then what we do is we take that number that we input, the 50, we're going to divide it by 2 to get 25, and then we're going to take 25 and mod it by 2 to get another binary digit, which would be in this case 1, because 25 modded by 2 is equal to 1. So then we take that 25 and we divide it by 2 again, which would be 12.5, but we round that down, so we just get 12. And then we mod 12 by 2 and we get 0. So then we take the number 12 and divide it by 2. We get the number 6 and we mod it by 2, which gives us 0. And then we take the number 6, divide it by 2, we get 3. And we mod it by 2, and now we get 1. And then we take the number 3 and take 3 and divide it by 2, and we get 1.5, but we round it down just like we did for the 25 when we divided it by 2. So we get 1 and mod it by 2, and then this is equal to 1. And then we're done. So now what does this mean? Well, this means, or I say therefore, 50 in binary is this number, these remainders in reverse. So starting from the bottom, we get our 1, so you just put 1 here, and then we get another 1 from here, so I'll put 1 here. We get our 0, so I'll put 0. We get another 0, so I'll put 0 here, and we get a 1, so I will put a 1 here, and then we get 0, so I'll put a 0 here. So our number 50 in binary is 110010. Okay? So again, I'm going to put a little note here. So note that our original number, which was 50, keeps getting divided by 2 each iteration. Okay, remember again, we first had 50 here, then we divided it by 2 to get 25. We divided 25 by 2 and rounded down because we got because 25 divided by 2 is 12.5, so it has that extra 0.5 there that we don't want. So we round it down. You do 12 divided by 2 to get 6. You do 6 divided by 2 to get 3. You do 3 divided by 2, and then you get 1.5, and then you of course have to round that down as well to get 1. So I just wanted to make that very clear. Okay, so how is our program going to work? How are we going to be able to reverse these numbers? Well, if we look at the binary number here, we see that the first 0 right here is in the ones place. The second 0 is in the tens place. This third 0 is in the hundreds place, and then uh, the next 0 is in the thousands place, and this 1 is in the 10,000th place, and then this other one is in the 100,000th place. So what that means is, in order to get our binary number, all we have to do is 10 to the power of 0 times our 50 modded by 2 plus 10 to the power of 1 times 25 modded by 2, and then put some space in here just so it looks a little bit better. Okay, plus 10 to the power of 2 times 12 modded by 2 plus 10 to the power of 3 times 6 modded by 2 plus 10 to the power of 4 times 3 modded by 2 plus 10 to the power of 5 times 1 modded by 2. And then we're done. Okay, so you'll notice that this right here, this side that we're multiplying by, is really just the same thing that we did up here, except for now I'm multiplying it by the ones place, the tens place, the hundreds place, the thousandth place, the 10,000 place, and then the 100,000 place. Because 10 to the power of 5 is 100,000, 10 to the power of 4 is 10,000, 10 to the power of 3 is 1,000, 10 to the power of 2 is 100, 10 to the power of 1 is 10, and 10 to the power of 0, of course, is 1. Okay, so it looks like we just need some type of loop here. And it looks like the only thing that's going to be changing are these values here, the 10 raised to whatever power, and the original number will be changing as well. It's going to be divided by 2 each time, rounding down. And we need to know when to stop. And it looks like we can stop when our value, our input value, or our in value, is equal to 0, or if it's maybe equal to 1, or if it's less than 1, something like that will be our stopping point. All right, so let's go ahead and finally get to coding. So first, let's include stdio.h header file. Then we're going to include our math.h header file, because this will contain our power function, which we'll use to raise something to the power. Let me do an example. Something like if we want 10 to the power of 2, well, we just write that like this using the power function, 10, 2. All right, and that will of course return 100. All right, and let's create our main function. Alrighty, I'm going to return 0. Okay, so first I want to create a few variables. So I'm going to create the number that the user will input, and I'm going to create its a variable for its binary equivalent. So this is just of course the variables. They're just going to be placeholders for our numbers. And then I want to say, please enter an integer, and I will convert it to binary. And then a new line. Actually, I don't want a new line. I'm just going to leave it just like that. Okay, then we're going to scan in the user's input. It's going to be an integer. And of course, it's going to be stored in the variable called num. Okay, and again, what we're doing here is we're just asking the user for a number to convert to binary. Okay, and of course, we need to then do the conversion, convert the number to binary, and then we need to print the binary number. Okay, so I'm going to create a function for that. So let's declare a function, and it'll be a decimal to binary function. It will let's see, it will return an integer value, and I'm going to call it dec2bin. Of course, stands for decimal to binary, and it's going to take in a value. I call it n. That will be our number that we want to convert to binary. And let me just say that this takes in a decimal number and returns its binary equivalent as an integer. All right, so that's what we want the function to do. It doesn't do it yet, but that's what it's going to do. So let's actually create this function now. All right, so first thing we want to do is we're going to have, we want to do basically what we did up here. So I'm just going to kind of copy it, and I'll paste it here just so I can look at it. Okay, so one thing that we notice is that this is in a loop, and that this value here, what 10 is being raised to the power of, is always incrementing. So first I'm going to create a variable called I, which will be the variable that increments, and maybe I'll set it equal to 0 because that's where we start here. So that's what our I value is going to be. Let's see, maybe we want a number value to store each of these places. Yeah, so that every time we add it up, we store this value. So that's what I'm going to need num for. So I'm going to set it equal to 0. And let's put in a loop. So while, again, I said this loop can run while maybe our number, which is here, 50, 25, 12, since it's going to keep getting divided by 2 each time, or divided by half, I want this to run until n is either less than 1 or if it's equal to 0. I mean, if it's not equal to 0. So run while it's not equal to 0, or while it's not less than, I'm sorry, or while it's greater than the value 1. So there we go. So this loop will run while n is greater than or equal to 1, because of course we want it to be 1. Or of course I could choose n not equal to 0. Okay, just want to make sure I didn't confuse anybody with that. I'm not sure what I said earlier in the video, but it should be this loop should run while n is greater than or equal to 1, or while n is not equal to 0. All right. So now what we want to do is we want that POW function. So we're going to do power of 10 to the power of I. And remember, right now I is equal to 1 times our n value modded by 2. And this of course is just the equivalent of one of these lines here. So this is 10 to the power 0, for example, times 50 mod 2. But of course I want to store it, so I'm going to use that num variable to store it. So num is going to equal that. And then we're going to add num here as well. So right now num is 0, so we're just going to add 0. But then num will be this number, and then we will add on to num this number here. All right. So of course now our n value, which is currently 50, needs to be divided by 2 and needs to round down. So all we have to do is do n divided by 2, or here we go, sorry, n equals n divided by 2. And the C language automatically rounds down for us, so we don't have to worry about using some function to round down. This will do it automatically. All right, and then we need to increment our I variable, because again, I is going to keep incrementing each time. It's going to be 0, 1, 2, 3, 4, and 5. Okay, I think that's almost it. After we're done with the while loop, then we just want to return our num value, and that function should cover it. So let's try it out. So here our binary number is going to equal dec to binary of num, and then we want to print it. The number %d in binary is %d. Maybe I'll do a new line, and then we of course print our num and we print our binary number. Okay, let's give this a run. I'll call it .c, and maybe I'll call this I don't know, toBinary, something like that. Save it. Oh, let's see here, what's wrong. Undefined reference to bin. That's because this is a lowercase b and not a capital B. So let's run this again. Please enter an integer and I will convert it to binary. So we're going to try, of course, our example 50. And we see that 50 converted to binary is exactly what we wanted. Let's look up here. Okay, so 50 is 110010. Exactly what we got here. All right, let's do another example. What is 2 in binary? Well, that should just be 10. And we see the number 2 in binary is 10. Perfect. And I don't know, one more number I can verify off the top of my head. Let's do 120. Actually, let's do 10, which I think is 1010. All right, yep, so the number 10 in binary is 1010. All right, guys, well, I'll definitely put the program in the description below. Please leave likes, any comments or questions you have about this program. I try my best to answer it. Don't forget to subscribe and to become a supporter on Patreon. Thanks as always for watching, guys, and I'll see you all in the next video.